In the mid-1990s, computer memory took a big step forward with the introduction of SDRAM, Synchronous DRAM. Instead of working separately like earlier DRAM, SDRAM operated in step with the CPU clock, allowing smoother and quicker data movement. This technology marked the beginning of faster and more reliable memory for personal computers, though it still had some limitations compared to modern standards. After the SDRAM era, DDR RAM emerged in the early 2000s as a major advancement. Its key feature was sending data on both the up and down bits of the clock cycle, effectively doubling throughput. As DDR evolved into DDR2, 3, and 4, memory became faster and more efficient, ultimately reaching today's high-performance DDR5. Over time, DDR technology has evolved to handle improvements to other components and has enhanced overall computer performances. Hence why some now refer to it as DDR1 as technology evolved. DDR2 was introduced in 2003 and operated twice as fast as DDR due to an improved burst signal. DDR2 uses the same internal clock speed as DDR, however the transfer rates are faster due to the enhanced input-output burst signal. DDR2 has 4-bit prefetch, which is twice that of DDR. DDR2 can also reach data rates of 533 to 800 megatransfer per second. DDR2 memory can be installed in pairs to run in dual channel mode, which can increase memory throughput even more. In 2007, DDR3 technology was introduced with not only 2 times the bandwidth and the transfer rates of DDR2, but a significant reduction in power consumption, roughly 40% compared to DDR2. This reduction from 1.8 to 1.5 volt meant lower operating currents and voltages, which was fantastic news for battery-operated devices. DDR3 transfer rates are between 800 and 1600 megatransfer per second. All these improvements meant higher bandwidth and performances with less power consumption, making DDR3 a great memory option for laptops. 7 years after the release of DDR3, DDR4 became available. The DDR4 has lower operating voltage with 1.2 volt and has higher transfer rates than previous generations, processing 4 data rates per cycle. This means DDR4 consumes less power and is faster and more efficient than DDR3. This newer generation also introduced bank groups to avoid having a prefetch of 16, which isn't desirable. With bank groups, each group can execute 8 bits of data independently from the other, so DDR4 can process multiple data requests within a clock cycle. DDR5 memory technology was released in 2021, and it is the most recent generation of memory technology, marking a revolutionary jump in architecture. It's arguably the biggest jump in memory technology since SDRAM. The main difference between DDR4 and DDR5 RAM is primarily in their speed, capacity, and efficiency. DDR5 offers significantly higher data transfer rates compared to DDR4. It means that it can handle more data at a faster rate, improving overall system performances. In terms of capacity, DDR5 modules can also store more data than DDR4 modules, allowing for more demanding applications and better multitasking capabilities. Lastly, DDR5 is more power efficient, operating at a lower voltage compared to DDR4. This not only reduces power consumption, but also generates less heat, which can help extend the lifespan of your components. DDR5 brings better channel efficiency, improved power management, and optimized performances. enabling next-generation multi-core computing system. DDR5 launch speeds deliver nearly double the bandwidth of DDR4. It also allows scaling memory performances without degrading channel efficiency at higher rates. These results aren't just during the testing but under real-world conditions. DDR5 memory standards is a denser memory stick and equates to more memory capacity in your system. In comparison, the DDR4 stopped at 16GB memory chip, but DDR5 offers up to 64GB memory chip in one memory stick. Overall, DDR5 is a more advanced and future-proof option for modern computing needs.